Welcome to day 2 of review of factoring. There were some guidelines for factoring completely, so if you remember them from yesterday, or if you want to pull out yesterday's notes, I'm going to give you a couple minutes to fill these in. So today, some more practice. We will do some in the video together, and then we'll do some together in class as a group. All right. There's no GCF here, so I'm going to take the 2 and the 2 and multiply. 2 times 2 is 4, and those add, and we want to figure out what they add to become 5. Well, 1 times 4, right? 1 times 4 is 4, and 1 plus 4 is 5. So what I have to do is I need to make that 5y into 1y and 4y. So I'm going to bring down the 2y squared plus 4y and bring down the plus 2. Did not space that very well, but now we're going to group those together. And we can factor out a y, leaving us with 2y plus 1. And then we can factor out a 2, leaving us with 2y plus 1. And I need to bring out a plus. So in one set of parentheses, I will have y plus 2, and my other set of parentheses will be 2y plus 1. And I'm going to box my answer. Okay, for C, let's see if this works again, the same method. You know what? I'm going to do C. I was going to do D because D is kind of tricky, but I think I'd like to do that as a class and see what we get. All right, so 5 times negative 3 is negative 15, and can we get negative 14? Oh, it's 15 and 1, and we'll just make the 15 negative. So we have 5d squared. We're going to split the negative 14 into negative 15d and plus 1d minus 3. And I'm going to group these. And then we're going to factor out a 5d. And that becomes d, right? Minus 3. Then here, there's nothing we can factor out, but we need something for the grouping to work, so I'm going to put a 1. And we have d minus 3. All right, so the d minus 3 is in parentheses, and the 5d plus 1 is in another set of parentheses. Box your answer. Okay, I'm going to pause for us to do B and D. Okay, let's see if this works. So we have 14 times 5. Well, 5 times 4 is 20. 5 times 10 is 50, so that's 70. And it's positive, but we need it to add up to a negative 17. For it to be positive, we can make both factors negative. 10 times 7 is 70. When we add those, we get positive 17. If we make them both negative, we get negative 17. So 14x squared, and then I'm going to have the 17 is going to break into negative 10x and negative 7x plus 5. We'll group these together. So we're going to factor out a 2 and an x to leave us with 7x minus 5. Now on this next one, that's opposite of that, so I'm going to factor out a negative 1, which leaves us with 7x minus 5, and then we can make our groupings of 2x minus 1 and 7x minus 5. Box your answer. Okay, for G, what's the greatest common factor? This one has a greatest common factor. 2. So then we have y squared minus 6y plus 5. Are there factors of positive 5 that give us negative 6? Are there factors of positive 5 that add to negative 6? Well, 5 times 1 is 5. If I make them both negative, it works. So y squared, and then negative 6y is negative 5y minus 1y plus 5. And then don't forget that we have our 2 out here. So I'm going to group these. And I factor out a y. And then I have a y minus 5 left. And then I'm going to factor out a negative 1 so that I have just y and a minus 5. And as you can see, those parenthesis parts are the same. And then we have the y minus 1 going in the other parentheses. And box your answer. Let's pause the video and do F and H as a class. For I, is there a greatest common factor? Yes. So negative 4 and also n squared. So this leaves us with n squared. We're going to have to make this minus because a positive divided by a negative is a negative. So negative 10n. And now we have a negative divided by a negative, so this will be positive 25. All right. And 25 is 5 times 5. And 5 times 5 is 10. If I make them both negative, then, this is a perfect square trinomial. Because if I write them as factors, it would be n minus 5 and n minus 5. But I could skip that step and just write n minus 5 squared, as you should. Okay, let's pause and do J. Ooh, for A, this one's interesting. Looking at this, I can see that there is a b in each term. But that's the only thing that I see that's the same. So we're going to factor out a b. Then we would have a squared c minus 4c plus a squared minus 4. I'm wondering what we could do with this. I'm thinking we should group it because there's 4 terms and then there's more that we can factor out. Okay. So, and it says make sure all factors are prime, keep factoring until you can no longer factor. This one's interesting. So we're going to do this, factor out a c, which leaves us with a squared minus 4. Then we're going to factor out a 1, leaving us with a squared minus 4. And we're not going to forget our b. We're going to bring that down at the end, okay? So then we have b, and we have c plus 1, and we have a squared minus 4. But a squared minus 4 is a difference of squares. So we would have b, c plus 1. We still have that. But the a squared plus 4 becomes a minus 2 a plus 2. Because if we factor, or if we distribute that out, we'll come back with a squared minus 4. So that is fully factored and pretty cool. Okay, zero product property. We want to find all the roots, identify any double roots. Okay. Let's rewrite this as x squared in standard form, so plus 4x minus 12. And that equals 0. Are there factors of negative 12 that add up to 4? Yes. Negative 12 and 4. So I would do 6 and negative 2. And because there's no number in front of the x, we don't have to do the whole grouping thing. We're just going to write x plus 6 and x minus 2 equals 0. And now we're going to do x plus 6 equals 0 and x minus 2 equals 0. So in this case, x equals negative 6 and x equals 2. Those are our roots. For b, first I'm going to factor out an s, and then I'll have s squared minus s. Oh, no. I should factor out an s squared, which leaves us with s minus 1 equals 0. Those are our factors. So s squared equals 0 and s minus 1 equals 0. If I take the square root of both sides, then s equals 0. That's one of our roots. Add 1 to both sides, s equals 1. That is our other root. Okay, now we have u plus 3, u minus 3. I'm going to subtract 8u, and that equals 0. Well, we can't use the zero product property on this because the minus 8u is not being multiplied. So what we need to do is distribute out and then see if we can find factors. So this is a difference of squares. When I distribute, I get 0 squared. I get 3u and minus 3, which cancels. And 3 times negative 3 is negative 9. Then we have minus 8u equals 0. I'm going to rewrite that in standard form. Can we factor this? Yes. It's weird that I write my first u with a tail and the other u's without. Okay. Or vice versa. What are the factors of negative 9 that add up to negative 8? Factors of negative 9 that add up to negative 8. Negative 9 and positive 1. Set these both equal to 0 because each factor would equal 0, or one of them has to equal 0 for the product to be 0. U equals 9 and u equals negative 1. All right, and you have some homework to help you review all of this before we get into chapter 7.